Hi everyone, welcome back. Today we are focusing on the practical case with the JFET amplifier circuit. We are giving that the source voltage of Vs should be 1 volt and our goal will be determine the drain voltage Vd. Let's dive in it. We are considering the 2N5434 N channel JFET as a G1 and 22 kilo ohm resistor as a drain resistor R1 and 3.3 voltage as a biasing voltage for the gate and the 5 voltage as drain supply voltage V2. And crucial information for today is Vs is fixed at 1 volt. Let us analyze the circuit with Vs equal to 1 volt. And we know that the gate voltage Vg is fixed. This is 3.3 volt from V1 and the Vs is 1 volt from V3. Therefore, the VGS is equal to Vg minus Vs, which is equal to 3.3 volt minus 1 volt and which is equal to 2.3 volt. Now we need to determine the JFET is on or off. From N channel JFET, it turns on when VGS is greater than VTH. That is, VGS should be greater than VTH. The datasheet 2N5434 specifies a typical value of VTH, often denoted as VGS off, which is between minus 1 to minus 4 volt. Since our VGS is greater than minus 4 volt, so we can conclude that JFET is in on condition. When the JFET is on, the drain current ID will flow through the resistor R1. To calculate the exact ID, we need to use the JFET characteristics curve ID versus VDS for the different VGS value. These are usually found in the datasheet. However, we can make a reasonable approximation for this analysis. Let's use the formula VD is equal to VDD minus ID into R1. And we know that VDD is equal to 5 volt and R1 is equal to 22 kilo ohm. From the datasheet, the IDSS consider as 30 milliamps. Since our VGS is 2.3 volt, we know that JFET is barely conducting. So we can say that ID is very small value. Let us assume the value of ID will be 0.1 milliamps. Then we will plug this value into the our equation. VD is equal to 5 volt minus 0.1 milliamps into 22 kilo ohm, which is equal to 2.8 volt. As we estimated, when Vs is equal to 1 volt, the Vd is approximately equal to 2.8 volt. The exact value of Vd will be depends on the specific characteristics of our 2N5434 JFET. However, our approximation gives us a good idea of the operating region. This scenario demonstrates how the input voltage at source voltage Vs directly affect the JFET operation and consequently the output voltage at the drain voltage Vd. By changing the Vs, we are essentially changing the resistance of the JFET, which in turn change the voltage drop across the R1 and thus Vd. And we can further explore this by simulating the circuit and observe the how Vd will change with a different value of Vs. Let us simulate the circuit. Here we are considering Vs as a 1 volt. So we can get the 1 volt at the Vs and Vg biasing voltage of the gate will be 3.3 volt and the difference between the VG and VS, the VGS will be 2.3 volt and current across the ID will be approximately equal to zero point 0.1 milliamps, and the voltage across the VD will be approximately 0.68 volt. For example, if I change the value of VD equal to 2 volt, our VD value get vary with a slight value. So we successfully demonstrated that when Vs is equal to 1 volt in this JFET circuit, VD is approximately equal to 2.8 volt. This exercise highlights the relationship between the Vs and VGS and drain current ID and drain voltage VD in a JFET amplifier. If you enjoyed this specific case analysis, please give this video a thumbs up, subscribe for more circuit breakdowns, and hit the notification bell. Feel free to leave the comments if you have any question or want to explore more scenario. Thank you. Thank you for the watching.